Good morning. Today we're going to talk about relations and functions. In this section, we're going to talk about finding the domain and range of a function. We're also going to use ordered pairs to determine if a relation is a function. And then on the back, we're going to plot these points and determine if the relation is a function. Here we're going to write the ordered pairs for the relation, and here we're going to make a mapping diagram for the relation. This is Chapter 2, Section 1, the first part. Definitions. A relation is simply a set of ordered pairs. They're related in some way, we just don't know how because it's a set of ordered pairs. We didn't come up with creating the set of ordered pairs. So for example, set A is this set of ordered pairs. 0, 3, -1, 2, 4, 4, -5, 2, and 7, -3. Remember, our ordered pairs are always x, y. Now, when we speak of the domain of a relation or a function, we are looking for which values? Do you remember? Well, it's the set of all x values. In the relation. All the x's. Now, if an x value appears more than one time, you simply just write it one time. If it's there 3 times, we don't write it 3 times. We just want to list it one time. And conversely, the range is the set of all y values in the relation. And if you think about it, x before y in the ordered pair, it's alphabetical. Also, domain and range, D comes before R in the alphabet. D, the domain, are the x values, and then you have your range, which are the y values. We're going to talk about a mapping diagram. So the mapping diagram links elements of the domain with corresponding elements of the range. So, for example, here we have a relation. It's a set of ordered pairs. We're going to find the domain and the range of this relation. You must use these curly braces, okay, because this is a set. I'm just going to go the first x value because I'm looking for a domain. -3, +2, -2, 0, and 1. In this case, I listed them all because none of them are repeated. The range values, again, it's a set. It's the y values. 3, +2, -2, 4, and -2, but -2 is already in my set of elements of the range. And so I'm only going to list it once. How do we make a mapping diagram? Well, you have these ovals. This one I'm going to call D for domain, and R for range. I'm going to put these in, I like to put them in increasing order. So -3, then -2, then 0, 1, and 2. It's customary to put them in increasing order. My range values are -2, +2, +3, and +4. And then what you do is you take arrows to indicate -3 belongs to what in the ordered pair? Well, -3 up here, move this down a little bit, -3 was paired with +3. So I just take and draw an arrow over to +3. +2 was an ordered pair with +2. So +2 in the domain with +2 in the range. -2 and -2. So I'm just drawing arrows. 0 to 4. Okay, that's an ordered pair. 0, 4. And then 1, -2. 1, -2. That's pretty much it for a mapping diagram. If you have questions, post it on the discussion post or ask a question in class. There are too many of you not asking questions in class. There's no shame. Please ask a question if you don't understand something. Definition. A function is a relation in which each element of the domain is paired with exactly one. I'm going to put that in caps and underline it. Exactly one element in the range. So each x is going to have its own y. You're not going to have the same x value being paired with two different y values. Okay, so I'm going to write that here in a different color. You cannot have the same x value paired with two different y's. If you have the same x value being paired with two different y's, that's not a function. If you have a graph, you can use the vertical line test to determine whether a relation has at least one element of the domain paired with more than one element of the range. So in this example, to see that, we are going to graph it. Now, this is not a graph of a function, so we're not going to connect the dots. This is just a graph of a relation. So I'm going to graph x is -2, y is 4. Put a dot there. I'm going to graph x is 1, y is 7. -3, 8. -5, -2. 0, x is 0, y is -6. And -2, -2. Now, if I were to look at my graph to determine if this relation is a function, I have to use the vertical line test. So it's like I take this vertical line and I pass it through the graph. If any two of these ordered pairs would be on this same line that's being created with my marker, then it's not a function. I could look here at this point and pretend that I'm drawing a vertical line. Only one element of the set of ordered pairs would be on that line. If I go here, only one element would be on that vertical line. If I bump here to this ordered pair, I notice that, oops, I've got two. So this is the same x value, -2, being paired with two different y values, -2 and +4. This is not a function. Now, to make this easier, you really should label the ordered pairs, A, B, C, D, E, and F. And -2, 4 was point A. It's customary to do this when you're plotting or graphing more than one function. So if you're plotting a bunch of ordered pairs, it's customary to label the ordered pairs as A, B, C, D, and E, or for however many points that you have. This was point E, and this one here was point F. So if we notice on our graph, points A and F would be on the same vertical line when we talk about this vertical line test. Okay, so label the ordered pairs. And here we're going to write when x equals -2 is repeated. So x equaling -2 is repeated. So this is not a function. -2 is being used twice with two different y's. Okay, and don't forget, 0, 0 is your origin. I'm not quite sure if you've ever thought of it this way, but really the coordinate plane is two number lines intersecting at both of their zeros. So I've got a number line going this way. You know, if I return it, here's my positive 1, 2, 3, 4, 5, 6, 7, 8, 9, and positive infinity up here. And then over here is my negative side. So that's the y number line. And then this is my x number line. And those two number lines simply intersect at 0, 0. And hence we have the coordinate plane. So because x equals -2 is repeated, it's not a function, and we say that this relation fails the vertical line test. So if you're asked a question, is the relation a function, you would say no, and if you were asked to explain why, you would simply say it's not a function because it fails the vertical line test. And in this case, it fails it at x equals -2. Not too terrible, I don't think. All right, let's look at this example. This is from page 59, number 7, and the example after that is also from page 59, number 9. This one says, write the ordered pairs for the relation. Find the domain and range. So I'm going to darken these in so I can see them. I've got a point there, got a point there, and there, and there. Excuse me, I also have a point here. This kind of looks like it's taking on a parabola shape. Now I could call this one A if I wanted, this one B, this one C, this one D, and this one E. All right. So when I write my relation, here's my relation. I'm going to put those ordered pairs in there. I've got -2, x is -2, y is 0. It's important that you use parentheses because they're ordered pairs, and it's important that you use the braces because you have a set of ordered pairs. And then I've got -1, 2. I have x is 0, y is 3. I have x is 1, y is 2. And I have x is 2, y is 0. So there is my relation, my set of ordered pairs. The domain, I'm going to use big D to indicate domain. Put it in stat notation, and I'm going to list the elements that are x values. -2, -1, 0, 1, and 2. And I'm going to do the same thing for the range, except this time it's the y values. So I'm going to choose these y values. I've got 0. I've got 2. I've got 3. I've got 2, but it's already in there. And I've got 0, but it's already in there. And so I only write them one time. Write each element just one time. You should not be writing these more than one time. Again, if you have a question, please ask, either in class or on the homework discussion. This example says to make a mapping diagram for the relation. All right, well, I'm going to make my oval for my domain and my oval for my range. Elements of x go into the domain, -2, -1, 0, 1, and 2. They're already in increasing order. And my y values, 8, 1, 0, 1, and 8. 1 and 8 are repeated. I'm only going to put them in there one time. So I've got 0, 1, and 8. And now I'm just going to do my mapping based off of my ordered pairs. -2 gets mapped to 0. -1 gets mapped to -2 gets mapped to 0, -1 gets mapped to 2. Why do I not have, oh, I'm up here. So this is a mistake. Sorry. Okay, see, even the math teacher makes mistakes. And it's okay to make a mistake as long as you catch the mistake. Something wasn't making sense to me. So I'm going to white this out. And I'm going to keep the mistake in the video. I'm not going to re-record because that would be silly. All right, I'm here. This is a separate problem. I should have done this. Okay. -2 gets paired with +8. -1 gets paired with +1. 0, 0, 1, 1, and 2 goes to 8. Okay, so there's my mapping diagram, and again, it helps if you are looking at the correct relation when you're making your mapping diagram. So I don't think the concepts in this section of this part of the section anyway are difficult. Again, if you have questions, please ask them whether you're in class or if you're at home, post it on the discussion so that I can get back to you and give you an answer. Have a great day.